Thank you. Hello. It's only polite after all, isn't it? Yes, I'm Sally Goble. I'm the head of quality at The Guardian, and the title of my talk is Not Wrong Long, as opposed to Not Wrong Love. Is perfect software necessary in the world of continuous delivery? For those of you who don't know The Guardian, we're the second largest English language online news organisation in the world. We have around 9 million visitors a day. We won the Pulitzer Prize in 2014 for our online journalism. And we release, on average, around 100 times a day. So that's the context across all of our products. And that's the kind of context of this talk today, is releasing 100 times a day, rather. So the aim of my talk is to convince you that the changing nature of delivery of software means that we should fundamentally rethink our approach to testing, and that's what I'm going to try and convince you of today. And in order to do that, I'm going to answer 3 questions. What has changed in the nature of delivery of software? How did that change make us reevaluate the role of QA and the role of testing in the software development cycle? And what is it that we do now if we don't do testing? So, what has changed in the nature of delivery of software? I'm going to take you back, first of all, to the kind of olden days of software delivery, where the software you used, either as a kind of consumer or a business, looked a bit like this. So this is going back to the millennium now. So it came in a box with a whole bunch of documentation, and it came on a disk. And if you wanted to buy your software, you'd have to go to a shop like bricks and mortar, walk in the door, and you'd select your software, and you'd pay with actual physical money, and you'd buy an actual physical thing. You'd take it home, and you'd get out your installer discs. And if you were lucky, your installers were DVDs. If you were unlucky, they were CDs. And if you were really, really unlucky, you'd have a whole bunch of floppy disks. And you'd install your software one at a time, disk after disk after disk. And that's what you do. That's how you get your software. It would be physically delivered to you. And if you wanted to update your software, you'd probably have to wait a year or 2. And then you'd go through the whole process of getting your update. You'd go to the shop, you'd get your money, you'd buy your box, you'd take it home, you'd install your disks. And it would be like that. And your software had to be perfect. Your software had to be perfect. The reason your software had to be perfect was because there's no going back, right? Your software had to be fully featured. It had to have great comprehensive documentation. And of course, from my point of view, from a tester's point of view, it had to be bug-free. And it had to be bug-free, and it had to be perfect. Because if you shipped a bug to production, you're going to have to wait a year or maybe 2 years even until you could fix it, right? So the physical nature of the delivery of your software meant that it had to be perfect. It was non-negotiable. Rhythm of delivery meant that you had to have perfect software. So while we were busy creating this perfect software, something else was happening along the line. The internet came along. So in the year 2000, 30% of the developed world had access to the internet, but that was modem, dial-up, internet connection, very slow. You move on to 2015, 16, 80% of the developed world has access to broadband internet, whether that be mobile or whether that be fixed line. 3.2 billion internet users worldwide. And that's changed the nature of delivery of our software. Changed from delivering it in a very, very physical form to electronic delivery. And that's meant that the frequency at which we ship our software obviously has changed from once every year or once every couple of years to once every few months, to once every few weeks, to once every few days, until nowadays, quite often, you don't even know that your software is being updated. It just happens. But how did that change the role of QA in testing? That was my cliffhanger. So obviously, we've gone from slow delivery in 2000, this is the kind of context of what I'm talking about, to continuous delivery now. And I'm going to take you back to the beginning of my story working at The Guardian, where I like to call our delivery fast-ish. So that's when I started working at The Guardian in the development team there. When our software delivery looked a bit like that, it was fast-ish. We delivered our software once every couple of weeks. So when I'm saying our software, we had a kind of one big code base that was our front end of our website, and also our editorial tools that our journalists used to create our content. So I worked on the team that looked after the software for our website and our tools. And we delivered our software once every 2 weeks, and that was pretty painful. So we had all the trappings of a 2-week release cycle. We had release managers, we had code freezes, we had staging environments, we had go, no-go meetings, we had the whole lot, and we had huge, interminable regression test suites that took 2 people 2 days in order to test them before they went, to test that code before we went live. But it was really important to us at the time to test everything perfectly, because we could only release once every 2 weeks. The reason we could only release once every 2 weeks is because we'd made some bad architectural decisions in the past. So the front end of our website was tightly coupled to our editorial tools, and we couldn't release without downtime to our tools. So basically, every time we did a release, our journalists couldn't produce any content. So we had to schedule our releases in once every 2 weeks at 6 o'clock in the morning on a Wednesday. And goodness help us if there was a cricket match on at that time, or somebody had died, we'd have to stop our release and reschedule it for 2 weeks further on. So we couldn't release without any downtime. We couldn't roll back our software. And also the deploy process itself was very long and complicated. It took an operations person kind of an hour and a half of kind of manual scripting in order to do a deploy. So the whole process was kind of long and complicated, which meant as the QAs, we had to ensure everything was perfect. So as an engineering team, we decided that this wasn't ideal, and we were going to kind of work towards trying to release our software more quickly. So kind of the engineers went away and embarked on a project to kind of move towards continuous delivery, or rapid delivery is probably a more accurate term. And so they fixed the problems with the coupled front end and tools, so decoupled them and made it so that we could deploy without any downtime. And we fixed the problem of no rollback, so now we could roll back whenever we wanted to. And we fixed the problem with the specialist having to do our deploy. So we created an in-house tool that meant that anybody in the department could deploy to any of our environments at any time with a push of a button. And so we were good to go, basically. We were good to go, and we started releasing our software more frequently. So once every week instead of once every 2 weeks, once every few days, once every day, several times a day, until ultimately we were at the position where we were deploying our software around 100 times a day, which was fantastic. Except it wasn't fantastic for the QA team, because we still were working with our 2 days of manual regression. And so the QA team, QA process had become a bottleneck to releasing, and we needed to speed up. And so we did what every QA team, so this was about 4 years ago now, did what every QA team at the time was doing. We thought, got to speed up our tests. So we hired an automation engineer, because that was what you did at the time, at great expense, who knew about Selenium and was kind of the great white hope. We hired an automation engineer into the department. We took one of our best technical QAs, and we took them and we sent them in, we put them in a room, and we said, can you automate all the tests, please? All the regression tests. Can you just automate all of those? So they sat in this room, and they wrote some tests, and then they wrote some more tests, and then they wrote some more tests. And by the end of a year, they'd automated all of our regression suite, which was amazing, except that it wasn't. It was terrible. The tests were awful. The tests were flaky. The tests kept breaking. The tests took too long to run. The tests needed constant refactoring and constant adding to as we changed our code base. Like, everybody in the department hated the tests. So we were kind of standing there thinking, what can we do about these tests that everybody hates? And we had a Eureka moment. We suddenly realized that we were kind of thinking about the problem in an old-fashioned way. We suddenly realized that the automated test was solving an old-fashioned problem of needing the software to be perfect. We realized that we didn't need our software to be perfect because we could just fix it if we broke it. So that's what we decided to do. We threw away all of our automated regression tests. Got another cliffhanger here. We threw away all of our automated regression tests and decided to change our approach. So we'd thrown away all of our manual regression tests because they were too slow. And then we threw away all of our automated regression tests because we thought we didn't need them. But we were okay, right? Because we still had like manual feature testing that we were doing, and we just thought it's a fine because we'll find things in our feature testing that we wouldn't have found in regression. So we were still doing that. But we got to the point then where we were releasing our software multiple times a day. So we could kind of scope out a feature in the morning and be shipping it in the afternoon. But we were still like doing this kind of locked into this manual feature testing. And I don't know about you, but like most QAs that I know, and this is one of the things I love about QAs, you give them a feature and they will test that feature to destruction. They will like find every edge case going, they will find every bug, and they will take a long time doing it. And we suddenly realized that that process of testing, manually testing features, was also not compatible with releasing multiple times a day. So we decided to stop doing that as well. So instead, what we have now is a culture of light touch testing, where we do the bare minimum testing that we possibly can to get a feature out of the door. And what's more, that testing isn't done by the QA team. So we basically have a distributed approach to our testing, whereby really anybody in the team can be responsible for the testing of that feature. It could be a developer, it could be a product manager, it could be a designer, and it could be a QA. It really could be anybody in the team just doing the bare minimum of testing that we needed to do to get a feature out of the door. But we also realized and recognized alongside this that we had to have an attitude of not wrong long, that we needed to make sure that if we shipped a bug to production, that we'd find it and we'd fix it as quickly as we could. So that was where we were going to spend all our effort. So when I kind of talk about this approach to people, they just look at me like I'm completely mad, and they say, isn't that a risky approach? It's all right for you. You're just a newspaper. You're just a website. We can't do this. In fact, I think somebody said this in Michael's talk earlier on. You can do that, but we can't do that because we make lots of money. And if, which obviously the Guardian does as well. Look, this whole approach is based on the ability to kind of ship continually and fix things if you break them quickly. If you're in the nuclear power industry, or if you're creating the software for self-driving cars, don't try this approach, right? But anybody else, I would say, can try this approach to kind of releasing their software quickly. But obviously, that whole thing is predicated on this kind of philosophy of not wrong long, and we have a whole bunch of a kind of toolbox of techniques, if you like, that we use in order to minimize the risk of shipping bugs to production, and they're kind of well known in the world of continuous delivery and continuous deployment. We have single feature releases, so we make our features as small as possible so that we mitigate the risk and we can trace them back to the code that caused them. We have aggressive caching on the website, which buys us a bit of time if we do find a problem in production. And we have feature switches or feature flags on all of our code that goes out. And for particularly risky features, we use canary releases. So we might just deploy a feature to a kind of small proportion of our users at a time if we think it's going to be risky. And of course, we have a whole bunch of monitoring and alerting, the standard kind of engineering-led monitoring and alerting that you're all familiar with. But as well as that, the kind of QA team has started kind of working on post-release techniques and beta programs in order to kind of mitigate the risk. And I'll talk a little bit about those in a minute. So, what do we do now? The QA team at The Guardian there are 12 of us, and half of the team are engineers. And obviously, if we're not testing, we must be doing something. So I'm going to kind of talk through a few of the things that we do now that we're not testing. The first thing that we do is we kind of recognize that testing is not the same thing as quality. And all of the things we do are trying to improve the quality of our products in the kind of very broad sense, and they're not just about testing. And it's funny, the irony of this is that we used to call ourselves a QA team and talk about quality, and all we were doing was testing. And now we kind of look at quality in a kind of much broader and more holistic way. So the first thing that we do now, I said to you, is that we kind of have this distributed approach to testing and quality. And what that really means is that we need to kind of enable other people in The Guardian more broadly to kind of come on board with kind of the idea of testing and improving quality as well. So we kind of work in this in several different ways. The first thing we did when we kind of took this approach is to try and make kind of tools and metrics available to everybody in the department, in the digital team, so that if they wanted to do some testing, that they would know where they needed to kind of focus their efforts, if you like. So we started creating dashboards that displayed all this information. So we'd always had this information as QAs available to us, but it had been pretty hard to find, and you needed kind of to be quite dedicated in order to be able to find it. So we started creating dashboards so that if you wanted to test something on our website, you'd know what the top operating systems and browsers were, to enable other people in the team to feel confident about testing in the right place. So we looked at our digital team, and we started helping them to think about quality. The next thing we wanted to do is talk to our commercial team. So they approached us, and we'd always had problems with ads on our website, as you do. Video ads started auto-playing when our users didn't want us to, or an ad would expand and cover the content. And our commercial team had said to us, can you test our ads for us? And of course we said, no, we don't do testing, but we'll help you to test the ads yourselves. So we wrote an advertising principles charter for our commercial team that outlined the technical specifications and the non-technical requirements that the ads on our website would need to pass in order to be on our live site. So we kind of facilitated the commercial team doing their own testing. And then the last part of the kind of trio of departments in The Guardian were our journalists. And so we had this really interesting problem in our live environment where we had some content on our website that is a kind of a rolling live blog of events that can last for 12 hours, covering a particular event on a day. And those pieces of content were having too many kind of embeds in them, and were crashing our users' iPads and sites sometimes. And we wanted to kind of think of an interesting way of tackling that problem. One of the ethoses we have at The Guardian is to not stop anybody from publishing anything. So we wanted to change the focus to our live environment. So we basically created a tool that polls our content API every hour and gets a list of all the content that's been published in that hour, and it kind of sends it off to a web page test service or to SpeedCurve, and it does an analysis of the page weight of both the page and all the bits of content on the page, and it alerts on if we've gone over a threshold of an acceptable page weight and page download speed for a particular piece of content. But the great thing about this tool is it doesn't alert us. It alerts our journalists and our editors. And so when a piece of content goes over a particular size, it sends off an alert by email to a particular journalist and says, you need to take evasive action on this page. And it lists all the embeds in that page that are problematic. And it's up to the journalist to go into that page and change the format of the video that's embedded, or take a few tweets out, or resize the picture, or so on and so forth. So we're kind of really pushing the responsibility for improving quality to our journalists as well as everybody else. So we try and get everybody else in the team to think about quality. That's the first thing we do. The second thing we do is we try really hard to focus on finding the problems in production. So that kind of whole ethos of not wrong long is really important. And it's important for us to acknowledge that using this strategy will result in bugs being in production. There's no doubt about it. But, you know, to be fair, we always had bugs in production before we started using this technique as well. But it's interestingly enough, we find the problems much more quickly in production now. So our whole mindset has changed from being one where we really focus on what's happening before production and then throw it over the wall into the live environment and go, oh yeah, well, we tested that, it'll be perfect. And now we know that because we're not doing that, we kind of focus all our attention in production to find the issues as quickly as possible. I'm going to give 3 little examples of the sort of things we do. So this example is of a team where we have one, which is a product, which is a payment system on our website, where we have one critical user journey that we absolutely can't break. And lots of different people are deploying and releasing in that environment. And we have to have absolute confidence that each deploy to production, each release to production, doesn't break that one critical user journey. So what we did to start with was we had a test that ran with test data in production, post-deploy on every release, and that test, when it succeeded, it flagged in GitHub in our developers' workflow that the test had passed, and that was great. So it gives you confidence that a particular release hasn't broken that one critical path. And then after a little while of having this particular product in production, we realized that our users were completing that critical user journey frequently enough for the actual live users to be used as an alerting system. So now what happens with this particular tool is we deploy to production, we listen for one of our users to have completed that critical user journey, and then that posts to GitHub that release has been successful, or it hasn't broken this particular user journey. The next iteration of this tool is for it to notify on failure rather than notifying on success. The second tool that we use in production is solving a kind of slightly different problem. So in this particular circumstance, this is our editorial tools. And we have, we wanted to create a tool that not only worked on release, but gave us confidence 24 hours a day that we weren't breaking a particular critical user journey. So our editorial tools are used sporadically. So they're used during the day quite a lot in the UK, but they're used overnight as well. And there's one particular thing that we can't break, which is the ability to be able to publish a piece of content. So we have a test, so a test that runs in production in our live environment in a special hidden part of our site that runs. It's super fast, it's super reliable. It runs every 2 minutes or so, I think, 24 hours a day, and alerts us on failure. So we have confidence that if this system breaks, or if this critical user journey breaks, that we're going to know about it before our journalists do, before they alert us. And they're only one floor down from us, so it's pretty good and reliable tool. The third example of how we try and spot failures quickly is an interesting one which we use in our apps. So it's slightly different problems on our apps because we have fragmented user base, and we want to know that sometimes that problems that are happening in kind of quite kind of less traveled parts of our app are not broken. We realized that we already had a huge amount of data that was being generated by our in-house analytics and tracking tool that was being collected for our business use. And we already had it, and we decided that we were going to use this to try and spot problems in production on our app. So we know what normal looks like in terms of users using particular features, and we use it to kind of spot anomalies in behavior in features. So we know in this case that our follow tag, there's got a smaller number of users than usual on iOS 9, and that we should investigate that to see if there's a problem with that particular user journey. So those are 3 examples of things that we do in order to kind of spot problems quickly in production. The third thing I want to talk about, which is interesting, is crowdsourcing our users. So in this whole process of kind of relaxing our attitude to testing, or letting other people distributing our testing, we distributed to our production team, we distributed it to the company, and we decided that we were going to start using our users to do some testing for us as well. The Guardian's really lucky because we have millions and millions of really super engaged users, and we realized that we could use them as a resource for doing some testing for us. The obvious place to do this was in our mobile apps. It was a really interesting case because I've talked about how releasing really frequently allows you to kind of have this approach of not testing. But obviously that's kind of not as easy to do in your apps because Apple's release cycle and kind of users' reluctance to download your app means that you probably can only release your app once every kind of couple of weeks if you're lucky, once every week perhaps. But every time we kind of went over to our mobile team, we were kind of still stuck in this kind of old-fashioned mindset of having to do rafts of manual regression before we released to production. And it would just really kind of jarred with us because we were used to working in a very different way. But we decided we still wanted to kind of go ahead with kind of not doing any manual testing. So we decided to spend all of the efforts that we had been spending on manual testing, creating beta programs, alpha and beta programs, in fact. So now we don't do any testing on our mobile apps as well, but we have large beta programs in both our iOS and Android apps. I think we have around 16,000 on our Android app and a couple of thousand on our iOS app. And we release betas, probably about 6 or 7 betas for every production release that we do are to our beta programs. And they're like an amazing source, a rich source of testing. I don't know if there's anybody here from any crowd testing companies, but I don't know why you would use a crowd testing company when you could use your own users. And they're super engaged, and they're happy to tell us if there's a problem, and they're also happy to tell us if they don't like a feature. So it's kind of got a double whammy, really. The kind of the final stage in all of this kind of crowdsourcing our users was to incorporate what had been our kind of first line technical support for our users into the QA team. So previously they'd been kind of a sad and forgotten dusty team that sat downstairs in another part of the building. They were really on the kind of forefront of answering emails from or phone calls from our users, telling us about typos we'd made or features that they liked or didn't like, and also reporting technical issues to us. So we decided to incorporate them into the very heart of our QA team and in the very heart of our digital team. So they came upstairs and they sat with us. Now our user help team they go to stand-ups, they go to planning sessions, they know the features that are coming, they talk to our developers all the time. This is our chief digital officer on the left-hand side sitting with one of our user help. So they're really incorporated right into the kind of middle, into the heart of our development team. And I kind of like to think of them as kind of their own little kind of monitoring and alerting system, human monitoring and alerting system. They feed back questions from our users right to the heart of the product team and allow us to really kind of shorten the feedback loops for the product. So that was a great success. So those are some of the things we do in our team now that we're not doing testing. And so my aim was to convince you that the model of software delivery means that you don't have to have the traditional approach to testing. You don't have to be fixated with testing. You can fundamentally change the way you do things. And just quickly to outline the benefits of this approach. The most important benefit of this approach is that QA are not a blocker to production anymore. They're not a blocker to release, and that you can consequently release your features to your users as quickly as you possibly can. Your stakeholders are happy and your users are happy. The second interesting benefit of this approach is that everybody cares more about the things that you deliver. Everybody cares more about the quality of your products. You've kind of taken the safety net away from everybody, and really it means that everybody thinks about quality in a different way. In fact, we have a rota now on that user help, on our user help team, and we have developers and product managers and UX people spend a day with our user help to really get an insight into what our users are experiencing, and they're all like totally on board with finding out how to improve quality. And then the third benefit of this is the kind of QA team are no longer feel like they're the kind of barrier to production. They're all happier and much more creative in the things that they do to improve quality. I guess finally, I want to end up with a picture of Henry Ford, and he was attributed to have said it. I don't know whether he actually did. If you'd asked for their customers what they wanted, they'd have just said faster horses. I think the traditional approach to QA these days is just to speed everything up. I think automated testing in terms of the QA sphere is just faster horses. And I would say to you, don't ask for faster horses. Invent the motor car instead, or otherwise reinvent yourself. Don't think that you have to just go for the traditional approach to testing. Really kind of take a kind of different mindset about what the changes to delivery mean to the QA team. Thank you.